Okay, right. So this is the last question we looked at, was statics of frictions. And I think some people were a bit confused about it. So let's have a look. So we're going to max a box of 2 kilos resting on an inclined plane. Okay, so we just quickly draw the diagram. That's our R. That's going to be 2G. It's angled at theta, and we're told that tan of theta is 3/4. Right, so now, one thing to be really careful of. There is a first part of the question, and then there is a second part of the question. So a box of mass 2 kilos rests in limiting equilibrium. Remember, that's important. On a rough plane angled at theta above the horizontal plane when tan theta equals 3/4. Full stop. In the second part, a horizontal force of magnitude P acting into the plane is applied to the box. So let's do part 1 first. So part 1, what forces have we got? Well, let's quickly just put our axes in. Okay, so right, so what force have we got? Well, first thing we know is this is tan of 3/4. That means if I take a right angle triangle, that means that the opposite is 3 and the adjacent is 4. So we know that the hypotenuse is 5 using Pythagoras, which means then that I can say that sine of theta is 3/5 and cos of theta is 4/5. And we'll use that later. Okay, so for number 1. So remember, there is no force P. So it's a rough plane. So first thing, we'll go horizontal. I'll go vertically, sorry. So R is going up, and the only other force in the vertical plane is the weight, which is 2G cos of theta. Okay, so that's that. And then we want to go up the plane. So what force is going up the plane? Well, the only force acting against the weight must be friction. So that means that F is equal to 2G sine theta. Okay, so now F, if this is limiting equilibrium, is mu R equal to 2G sine of theta. Now we don't know what mu is yet, but we do know what R is. RG is 2G cos theta, and that's equal to 2G sine of theta. So now if we rearrange that, because we want to know what mu is, so mu, our coefficient of friction, is equal to 2G sine theta over 2G cos theta. And we know I've got 2G divided by 2G, well that's just 1. I've got sine over cos, which is tan of theta. So that means that our coefficient of friction is just as we were given in the question, equal to tan theta, which is 3/4. So now I've got my coefficient of friction. So now we can go to 2. So for 2, let's include our force P. Okay, and I'm going to extend that through. Oh, that's actually not very well drawn. Right, so let's do it horizontally. Okay, so that's P all the way through. So now, using our alternate angles, if that's theta, and using vertically opposite angles, that's theta. Right, so vertically, I've got R still. I've got no other forces going up, but I've got P sine theta, that's below my perpendicular, and I've got 2G cos of theta. And then I'm going to go up the plane. So what have I got going up? I've got P cos of theta. And in the other direction, I've got 2g sine of theta. That's my weight. Now, remember, it was in limiting equilibrium, but now I'm applying P, and I want the maximum P. So I'm going to see that basically I'm going to take my friction in the other direction, and it remains in equilibrium. So that's going to be Fmax. Right. So now I'm going to make my P cos theta equal to 2g sine theta plus, now Fmax we know is mu times R, and R is P sine theta plus 2g cos theta. Okay, so now I'm going to do a bit of factorising because I'm actually trying to work out what P is. So I'm going to get my P terms on one side. So I've got P cos theta over here. I'm going to subtract mu times P sine theta. And that's going to leave me with, on this side, 2g sine theta plus mu times 2g cos theta. Okay, so now let's take P out. So we'll factorise P out. P times cos of theta minus mu sine theta. And my common factor on the other side is 2g. So I've got 2g times sine of theta plus mu cos of theta. Right, okay, that's fairly tidy. So now, remember, we have got the values for sine and cos. So we're going to put them into our equation. So I've got P times cos of theta, which is 4/5, minus mu, which is 3/4, times sine, which is 3/5, and that's equal to 2g, which is 2 times 9.8, times sine of theta, which is 3/5, plus mu of theta, which is 3/4, times cos of theta, which is 4/5. Okay, if I multiply all of that out, I get 0.35 times P equals 23.52, and that means that P is equal to 67.2 newtons, and that is my max because we used Fmax to keep it in limiting equilibrium. Okay, so remember the most important things from here were we used our triangle to find sine and cos, which meant we could do lots of substitution. We broke our question down into two parts, and the first part allowed us to work out what mu was, and then we put in our force of P and worked out what P was. Hope that helps.